Here I'm creating a hand unit gauntlet, the polymer part. So what I did was, I stacked the sheets together. I applied copper, aluminum, and another sheet of copper together. And I did this for the Faraday cage lure. So now the other part I'm going to add is the foam. The idea is what I'm doing is blocking the microwaves from passing through. The more I restrict the subatomic matter microwaves, the lesser it passes through the system, so that it has a torque force, a densified torque force, when I use a winding coil, Hall effect, or magnetic suspension coil local to its surfaces, will cause it to move away from the microwave magnetic field that is common to its polarization of the transductor. So when I use the foam is also to block more of the microwaves from passing through, from propagating through, which is subatomic microwaves. The subatomic microwaves are the alpha particles and lower alpha particles, which are 25 steps all the way to omega waves, particles. The omega particles is the last particle of mass, which is subatomic quantum mass. And the subatomic quantum mass, when it has resistance, it enables the force to be like almost instantaneous. So it's like similar to almost pure neutron force when using the kinetic energy of a transductor to pulse against it, to where the peaks are more instant, because of the resistance of the particle wave microwaves that cannot escape through it. So what it does is it moves back through the electrodynamic radiation pressure and force, which is the ampere, which is actually the pressure of the velocity of the electrons ions transmission, or ions displacement. And the collision against it is the torque collision against the resistant, which resists the microwaves. So the more I bind this, no matter how thick it is, or no matter how much it weighs, the more I add a restriction of the Faraday cage law, what happens is, as far as Faraday cage is a microwave blocking, the more I block it, the lighter it gets against the Earth's gravity. If I throw it in the air, it should come. This is how I test it. I throw it in the air to see how fast it's going to fall to the ground. That's how I determine how much sheets I need to block the microwaves. The more I add, the more restriction it has by the matter, the atmospheric matter that collides against it once I throw it in the air. While it falls, it has a resistance by particles that passes through it. While the mass falls down, it resists it and causes a restriction on its fall. So it slows down in speed. Maybe similar to how a magnet is placed within the cylindrical of a copper and slows down because of the Newton force and the wavelength of the microwaves. That causes also the restriction of the permanent magnet's fall. So when it causes a static restriction, it allows it to fall slowly. The slower it falls, while it is not held by any mechanical, but only subatomic or atoms that is localized around it. Only electrostatic that keeps it in restriction of its fall, of gravity, pneumatic's weight of gravity. So the same, where I reduce its natural weight of gravity and cause a restriction against its field or density, so that when I add the winding coil, the more the force, the more strength in the gate is of the closed microwave subatomic matter, which is more smaller than the electrons and leptons, so, and more smaller than atoms. So it's like 25 steps down. As long as I do that, the more restriction force. And then, when I add a reactor, there's a coil in it, I allow it to move away from the Earth's gravity into the air. So when I throw it down, it floats down like a feather, no matter how heavy it is in our hands. But when it is moved by a particle in space, when it's restricted by a particle in space, it restricts its fall, so it falls down slowly. So that's what I'm doing right now, and fixing up the enclosures of the armor, while at the same time doing the transductor transformer body armor. My name is Jermaine Morton, and goodbye. I'll be back with you after I finish this hand unit. So.